Hey, welcome back. I wanted to do probably the last Shoptalk video for this year. This is number 17 for 2018, and I have a whole lot of different topics this time. I get a new torch, got a new got a new power scraper. Wanted to show you a quick way to dress diamond cup wheels and a little bit more. So, hope you enjoy. Well, I had to do a fair bunch of silver soldering, hard silver soldering in the recent time on very small parts, and I used my usual oxy-fuel rig with a relatively small torch that I had for quite some time now. But the torch I had, this was given to me for free, and at the time I was very happy to get it because I didn't have a torch. And it worked really good for a very long time, but finally one of the valves, the fuel valve, seized up, and I rebuilt it a few times, took out the valve, polished everything up again, removed all the galling, put it back together. Then it worked for some time again, and just took all up again. So on the last job I did, this thing drove me nuts with the kind of broken valve. It was very inconsistent, and if you had it set to a very small pointed flame, it was not consistent at all. It changed the size and shape of the flame all the time. Not a very good thing if you want to do proper brazing or silver soldering. So I went on the internet, looked up what to buy, and I bought a Greggersen Micromax micro torch. This is the torch handle, all aluminum, metal body, very nice needle valves here, all made in Germany. Very nice piece. Made a holster for the torch here on the side of my bottle rig. I never had a full-size oxy-fuel rig with acetylene. I always had these 0.4 liter one-time use bottles and a 2 liter refillable oxygen bottle, and the setup is, for my purposes, absolutely enough. I get around about 1 year out of the O2 bottle if I do not have to do too much work. The smaller the fuel bottle, surprisingly lasts way longer than the oxygen. I think this is still the first one I had. So I have a proper regulator on the O2 bottle with flame arrestor, and on the fuel bottle I have just a needle valve and also a flame arrestor because I do not want to blow myself up. And that's my oxy-fuel rig. Very compact, you can carry it if you need it. You need to use it somewhere in the shop except for the bench. And I'm very happy with it. And now I will take you in closer so you can look at the torch. So that's the torch I was using. It's made by CFH, and you can get these in home improvement stores along with a set of one-time use O2 and fuel bottles. They sell a very small rig for that. It's okay for small work and occasional use, but for me, I have outgrown it. It's decent made. To change the tips, the size of the tip, you unscrew the end here and you exchange them. You have different sizes, and yeah, it's a torch. But this has to go because the valve here, the tapered seat in here is completely mangled up. So let's get this out of the way. Now I changed to this guy, Greggersen Micromax, made in Germany. This is the smallest torch, and it comes with this adapter here. Put this in, Put the nut on. Then you have these micro needles. These are stainless steel syringe needles with lure taper, and you have this quick change arrangement here on the end. You unscrew this nut, slide in the needle. It has a rim here. Slide it in, and you just tighten it down by hand like this, and you're ready to go to do relatively fine work with it. Let's slide this one up. This is a 1.4 millimeter needle. There we go. That's a very nice flame to work with. Very, very precisely adjustable. Boop. And you can blow it out with the oxygen, of course, if you go too far. But yeah, it's... oh, oops. But it's really a nice torch for very small work. This 1.4 millimeter needle can heat a surprisingly large part in no time. And changing the tips is very fast. Just get it out of the way, and we have, this is our smallest one. This is 0.8 millimeters. Get this in place. And that's even smaller. And with the 2-liter O2 bottle full, you can probably run this for half a year, I guess. I don't know. But this doesn't need much fuel and oxygen. That's the standard, and that's the micro-size torch. But Greggersen has one nice thing about their torches. Each size, smallest, medium and large size, can use the tips of each other system. So, within reason. They're all mechanically compatible. You could hook up the large cutting torch head to this baby torch handle. Obviously this one couldn't deliver enough gas flow to do any oxy-fuel cutting, but you can, for example, and the set came with it, this is a small rosebud burner with a large number of nozzles out here. This works beautifully. Just put it in here. I have to be a bit careful with this guy, not to set anything on flame. Give it a little bit of gas. Yeah, a little bit. Add a bit of oxygen. Get my That's a nice flame for heating things up. These small rosebuds, and there are also welding tips in this size. Obviously, as I'm not running acetylene, I cannot do welding with this. Propane cannot do welding, only brazing and flame cutting. I can use the larger tips for silver soldering and brazing, and change back and forth without having a problem. And if I ever buy a larger oxy fuel rig with a larger torch, I can also swap in between, which is a very nice thing. So that's the Greggersen Micromax. Comes in a nice steel box for all the accessories, and yeah, It's really, I like it. It's not cheap. The torch with all those nozzles and the rosebud burner you see here cost about 280 euros. But still, I will probably have this torch and all the accessories until I retire. Spare parts are not a problem. Replacement parts are not a problem. So it's I think it's a good investment. And yeah, a bit of a show off. Sorry for that. But to be honest, this guy here worked also. Was not a problem to do some very nice silver brazing. I silver soldered a lot of carbide onto steel shanks with this torch. It's just not as nice. You can see the handle of the Greggersen one is a little bit compactor, and with the adapter for the small nozzles is also shorter. So your flame is closer to your hand and you have more control over it. It's another different story with the rosebud because that's full size head. Yeah, that's my new setup for silver soldering and brazing and heating stuff up and setting stuff on fire. I need about 50 or 60 of these small pins. These are tungsten, pure tungsten, 1.6 millimeter in diameter and 5 millimeter long. Actually, these start out as a TIG welding electrode. These get silver soldered onto another piece. But I need to cut them up, and I figured the easiest and most consistent way would be here on the tool and cutter grinder, so I will show you my setup for that. I have my motor-driven workhead here on the table, and it's holding a 1.6 millimeter tungsten electrode in there, and I have a point here, a stylus of a surface gauge that acts as an end stop. And this green monstrum back here is a resin bond diamond cutoff wheel. And the way this works is I grab the end of the tungsten rod with a pair of tweezers, I open the chuck, I pull the rod up against the pointer of the stylus, tighten the chuck, turn on the spindle and the workhead, and cut off the piece. And obviously I grab the cut off with the tweezers so it doesn't shoot away in the shop and I will never find it. And then it's just repeat again and again and again and again until I have 50 of these small buggers. And here is the larger overview: motor-driven workhead, cutoff wheel. Down here is the surface gauge with the pointer that acts as an end stop. And that's the whole setup. I just feed in and retract. That's all. And once you get in the rhythm, this goes really very fast and easy off the hand. And also it's very precise compared to cutting them off with a die grinder and a diamond wheel. Today I wanted to talk about dressing and refurbishing resin-bound diamond grinding wheels, especially in this case cup wheels, because the technique I'm showing is only suitable for cup wheels that have their diamond compound on the face. Over time, when you use a diamond wheel like this on a grinder, if you're not very careful, over time you will you will round over the edge, and also you will end up with an uneven surface that has also some grooves in it. In this case I ground tungsten on it, and tungsten is very bad for the grinding wheel, and when we take a look with a straight edge over it, it's not really flat anymore. It has a few gouges in it, and overall shape is not very good. So there are a bunch of techniques how to dress and reshape a diamond wheel, a resin-bound diamond wheel. On a surface grinder you can grind it in. You can take a piece of soft steel and just grind for a very long time, and soft steel will actually wear down the diamond wheel and make it run true. You can also use a piece of molybdenum and use it the same way, which is a bit faster, or if it's a cup wheel like this, you can lap the wheel true again. All you need for that is a piece of plate glass, or even better, a proper lap-in plate, which I don't have. So I'm going for the next best thing, which is plate glass. You need silicon carbide lapping compound or loose abrasive. I guess that the loose abrasive would work better, but I do not have that. I only have the compound. This is 280 grit. Coarser would probably work better. The reason for that is the silicon carbide does not actually cut down the diamond of the wheel. It goes between the diamond and breaks the individual diamond particle loose and wears down the resin binder around it. So a coarser grit will work better for that, but this is all I have here. I have 280 grit and 400, and so this is the coarser one that I'm going to use. Plate glass, and you need something that will dissolve the compound. In my case it's WD-40. Petroleum would work too for this stuff. There is also water-soluble lapping compound. It's really straightforward. We get a little bit of the lapping compound spread out here. And this is really a horrible, messy operation. I will show it with this wheel, because the resin on this wheel has a reddish color, and you will see that the progress very fast. We add a little bit of lubrication. And then we just go to town. If fingernails on a chalkboard make you cringe, this will make you cringe really. When dressing a diamond wheel like this, you obviously have to take care that you do not introduce any facial runout in the wheel. So you start to dress it, and you put it back on the grinder and check your runout, the axial or facial runout, and you go back to the lapping plate and you correct for this. But if you're careful during lapping, you will not introduce much of an error at all. So just be careful, keep even pressure, rotate the part from time to time, and you will not create much of an error. And by the color of the sludge down here, which gets kind of a reddish color, most of it is the silicon carbide that's breaking down. The rest of it is a little bit of glass that gets abraded, the resin binder of the reddish color, and a little bit of diamond. And you can check your progress with a straight edge pretty good. This wheel gets really flat now. It has a little bit of a radius left, but I probably will not lap it down all the way because I still want to have some diamond left on this one. Okay, this is my D40 lapping wheel, diamond lapping wheel, and I have a light source behind it and my straight edge here. And when we get down onto the wheel, you see this gap of light here. There it's gone. That means that we have a very good fit against the straight edge, and that means that it's pretty darn straight surface on both sides of the wheel. This doesn't tell us anything about the facial runout, but at least it's already flat. As you can see, I obviously lost my marbles, and I bought a brand new Biax BL10 power scraper. I want to take the opportunity and show you the two known manufacturers of power scrapers that are left. One is Rentz. This is the Rentz A20 scraper that I had for years, and this is the brand new BL10 from Biax. Both are about the same size. The Biax is substantial lighter and also slimmer in design. The Rentz, the gear head in front here on the Rentz is very bulky and very heavy. The decision to buy the Biax, I wanted one for a very long time, especially after the scraping class in Stuttgart, where I used the Biax for the whole week to scrape in the table of my surface grinder. And I used a BL10 there. When I came home, I finished the job with my Rentz, and there was just night and day difference. The Rentz, whatever you do, it will tend to chatter. You cannot get around it. The Biax just scrapes smoother. That's due to the mounting system and the stroke mechanism in front here. The Rentz, you have this piston sticking out to the end of the scraper. This moves back and forth as a whole, and you have this wedge-shaped piece of steel here, and that's where the blade bolts to. On the Biax, you have a shoe here, very close to the housing of the scraper, again with an angled shoe here. That's where the blades slot in, and you tighten them down and you hold them in place. But there is a rubber mount in there, and you tighten the screw only very lightly, so the blade is still flexible mounting. You can see the rubber compress in here a little bit when I flex the blade. That's what you want. You do not want to tighten the screw down so you get metal to metal contact with this clamp against the shoe here. Then it will scrape awfully bad. Terrible. It will chatter like crazy. And this is really the trick behind the Biax, why it scrapes so good. I made the Rentz work for me by putting a shim of 1.5mm turkite, which is a bearing plastic, very soft Teflon material, in here between the steel shoe and the short stubby blade holder. This combination worked very well for me, but still not as good as the Biax. On the Biax, I just used the long blades, which are very flexible. The shorter blades are nice for roughing if you're very skilled and have to remove a lot of material. But they were tough to handle. I have one that came with the scraper, but I also have a full set of the long blades, even with the high-speed steel blade that doesn't work. High-speed steel positive rake is usually sold for scraping soft steel, but it doesn't really work. You're better off to scrape steel with a carbide blade. This is the short stubby blade I was telling you, 60 radius. I also have this one here. This is a rigid blade holder for the carbide blades. I think these are Sandvik, but to be honest, this doesn't work too well. This is too rigid. You would have to mill out an awful lot of material to make this really work. And it came with the template for grinding the radii, and also with the 25.4 by 25.4 millimeter square in here. yeah, it's a square inch with the razor edge. A lot of people are not really sure what this sharp edge on the blade here is, or on this template are. Some people use them to deburr surfaces, which can work, but once you put a single ding in there, you will scratch the heck out of your work. I'm not a big fan. I prefer stoning. There is also the blade that we reshaped to a 30 radius. 30 radius for higher point per square inch scraping. I will it came in this nice leather pouch. Better sit down when you get the prices for the blade kit. They're not cheap. On the Biax you have your stroke adjuster as usual down here. You just spin the motor shaft with your Allen wrench until you see the hex key in there. Go in, spin it, adjust your stroke that way. On the wrench, you have a square drive in front here, and there's a small wrench with an internal square put on it. Spin it and adjust your stroke that way. That's faster. That's easier. On the Biax is always a bit fumbly. You have always to find the right position for the motor shaft. That's not a big deal. Usually you're not changing your stroke length 20 times a day. The wrench has a fine motor, and the Biax still has an AG motor. The Biax already comes with this nice leather strap in front here, which you can. It's a little bit loose at the moment because I was using it like that. You can use it and you can hold it like this, like a front grip on a gun, or you can use it like this and tighten the strap a little bit down so it supports on top of your hand. Both ways go. The wrench scraper didn't came with anything. This leather grip here, a friend made this for the scraper. This is just leather stamped, cut to size and stamped the holes in it. Both are fully adjustable with speed control. The early wrench scrapers and the early Biax didn't have speed control. There is another wrench scraper, the A10, which has a fixed stroke of 6mm and no speed adjuster. And it looks very weird. It goes straight out here without the offset. It's very long and very awkward to handle. The A20 is a nice machine. The Biax look for the last 20 to 200 years like this, roughly. The very old models, the blue have a blue housing with a hammer tone finish and heavy as bugger, but they still work and scrape very good if you can handle them. So yeah, that's what I want to show you, comparison between the wrench and the Biax. While I have both of them here. I know you cannot buy the wrench from. I want to show you a close-up of the blade mount on the Biax, because a lot of people, when they get the used Biax power scraper, get this wrong. This is a steel piece here. All this is steel, and in here is a rubber wedge. And this is the blade with the slot. This goes in here. This is all steel. Plate goes in here. This piece slots in here. Ugh. Sure, not completely incompetent. And the screw goes in here. We tighten down the screw just a little bit. That's enough. There is still there needs to be a little gap here, about 0.5 to 1 millimeters between the steel shoe and this wedge-shaped part here. So the blade can still move and flex. When I bend the blade, you can see the rubber in here compress and be forced out to the side. If you crank down like crazy on this screw, I don't want to overstress the rubber in here. If you crank this down and you have no gap left in here, this blade is rigid. It will not move, it will chatter. doesn't work. So if you have a Biax, be sure to not over tighten this screw. Also, put some oil on these ways here. These are hardened steel on steel. Use some whey oil. The oil that came with the scraper feels like a 220 whey oil. Put some on here. Makes it last forever. The guide in here is also adjustable, and you can shim it on the back and whatever. Today, scraping project. This is the table of a 6S 101 watchmaker's milling machine. Beautiful machine. And the owner of the machine just wanted to give it a once over, check it, and scrape the table surface. So let's go to the surface plate, check it, give it, throw an indicator on it, see how the overall geometry is, and then figure out a way how to hold this upright so we can scrape it properly. First thing is to check the squareness between this mounting surface and the table surface. I have a toolmaker's block which is scraped to a very high degree of parallelism, squareness and flatness. Clamped against his face, large C-clamp, brass shim under the pad of the clamp, 2 micron Tesa dial test indicator, and we start out here at 0, and we move slowly over to the outer end of this block. And we're somewhere in the 2 micron range over the whole distance, which is pretty okay. It's just a milling machine. Of course, we have to add the tolerance of the surface plate, which is maximum 3.5 micron over the whole surface. We have to add the tolerance of the dial test indicator. The block has a tolerance, and of course gravity pulling down on the block and a million other things. So let's say it's okay. We should be well within 0.01 millimeters squareness between this and this. Also important, this face down here, which should be parallel to the table surface. This indicates the tram of the table. If you butt this up against the x-axis of the machine, the table surface will be flat or trammed in, however you want to call it. Okay, 0, 4 micron, 2, back to 0. It's slightly hollow in the middle, 4 micron hollow at 2/10,000ths of an inch. Also pretty good. I believe all the mounting surfaces here alone. The owner of this table just wanted me to scrape the top of the table for effect, but I don't do that. If I scrape it, I will scrape it for bearing, at least 10 to 15 points per square inch. Otherwise it's just faking it. I don't like that. We'll scrape it, we'll keep the geometry as it is. The overall geometry to the mounting surface back here. Just give this a nice bearing and a nice pattern. Well, I guess I guess I'm a woodworker now. Bolted together a quick fixture to hold the table rigidly for scraping. It drops in this frame, it rests on those two square pieces of wood, and those 2 strips of plywood keep it from sliding back and forth. And I have this cross member down here where this mounting surface rests against. In itself, this is probably rigid enough to scrape, but if I really get problems, I can reach down here with a clamp and clamp the clamp the cast iron table to the wooden fixture to make it appear as one piece. But I won't probably need that. I guess it will be enough if I clamp the fixture to my table. You might notice that these pieces of wood have numbers written on them. That's their length. I need to very often to make quick fixtures for scraping machine part, and dragging out the chop saw every time and cutting out construction lumber gets odd over time. So I made a kind of a system. I have a huge number of different length and different sized blocks pre-cut, and I write the length of them on the face of them, so I do not use them for something else like firewood. And I keep them separate from everything else, and I always use them for quick fixturing like this, and when I'm done I just unscrew everything and drop them back in their box and keep them. It's like 1 to 3 blocks for woodworkers. Okay, after the last pass I took it over to a surface blade and I blued it up, and as you can see there's a lot of blue, but not everywhere. In here, this didn't hit very heavy on the surface plate. This didn't hit on the surface plate very much, only a little bit compared to the extreme other edges of the table. And also out here it didn't hit very much. So we're going to do another roughing pad, semi-roughing pad, and we're just going to hit the areas where the bluing hit relatively heavy. We'll complete spare out these red marked areas. I guess 1 or 2 passes and we're in. Shouldn't take long. My scraping technique here is a little bit odd. I'm scraping with relatively low pressure, still taking a chip of course, but not as heavy as I would if I was scraping a sliding surface. I'm doing this because the table is just a mating surface, bearing surface. I don't need oil pockets on there. It just needs to be flat and has a good overall bearing. Okay. It took 2 more passes to get the hole in the center out. As you can see now I get kind of an even bluing all over the surface of the table. Basically it's pretty much done. I will take a few passes with reduced stroke length and our 60 radius blade now, just to improve the bearing pattern a little bit. As it is right now, it's a little bit all over the shot. It's really hard to film a scraped and blued surface. I hope you can see it in this shot, that I get blue markings all over the face of this thing. And now we go specific for the blue spots, for the high spots. When you're scraping for points, the easiest technique is to look straight down on the blade and almost lock your view onto the tip of the blade and move the blade from point to point and just drop it down on the point, and you will have a very easy time to hit the individual points that way. Blowing off the chips, deburring with precision ground flat stones, and done. Here's a screenshot of the table finished scraping. This is how it blued up after the last pass of scraping. Good 25 points per square inch with roughly 40 to 50% of bearing. And this is without the bluing. Very even pattern. I'm very happy. This is going straight back to the owner of this small 6's 101 milling machine. Hope you enjoyed this weird mix of different topics. Thank you all for watching, and this being end of the year and probably last random talking video of me, I want to thank you all. I just got about 45,000 subscribers, and this is well beyond anything that I would have ever expected for this channel, so thank you all. Please keep it as civilized in the comments as it is at the moment. This is really great. The ratio between good comments and crack comments is very good. Hope it stays that way. This being said, Merry Christmas, Happy New Year, and just have a few great days off. Just enjoy family life and what you like to do. So see you next year. Thank you all for watching.